In this tutorial, we'll be covering how to interface with an LCD display using the KL25Z. LCD displays are great for projects when you need to display simple information. There are many different types of LCDs that you can find, some with more or less space to write things on them, but this tutorial will be covering the 16x2 display, and it should help to give you a good understanding of how to program them, and you can pretty much scale up to whatever kind of dimensions that you need. The one that we're using is actually ordered from Adafruit. A little perk with it is that it has a multicolor backlight, so let's go ahead and get started. Okay, so there's going to be a variety of different shapes and sizes to these LCD displays. So it's important to kind of look at the spec sheet. But generally what happens is at the top over here, typically there's like 14 to 18 pins depending on the configuration. But the most common pins you'll see are VSS, which is just another way of saying 0 volts or ground. VDD, which is a positive voltage. In the case with our LCD, it's going to be 5 volts. V output, this is the one that helps to regulate the contrast. So what you're going to pretty much do is you're going to give it like a variable voltage to adjust the contrast appropriately. This is a read select, read write. We're not going to be using the read write command. We're actually using only the read select. E is for enable, and then these are the digital pins that we're going to be to interface with them. You can see here that there's 8 pins, but the one we're going to be using, we're going to use 4 pins because adding an additional 4 doesn't actually improve it. It makes it only slightly faster, and you waste 4 pins. We're only going to use the digital pins 4 to 7, and then for this Adafruit one, there's a special thing right here which actually controls the backlight. So LED plus is the positive voltage, and then if you ground any of these, you'll actually use red, green, or blue. But these are auxiliary. Typically, you only have 14 pins for a typical LCD display, and we're going to go ahead and look it up on the actual MBED library on how to actually interface with this thing. So let's scroll over here. So the library is called Text LCD, and it's enhanced. So there was an old version of this that had only a few ways of interfacing with the LCD display, but some people actually updated it and made it so that you can actually use a variety of different ways to actually interface with this. So the one that we're going to be using is the parallel bus wiring. So there are these other ways, I2C and SPI, which we'll discuss in another lecture tutorial video. But we're going to go and look at the parallel bus wiring, which is the original way of actually interfacing with this. So you can see right here, we already have a ground or VCC. This is VSS, VDD. And the way that they suggest it is give this one 0 volts, give this 5 volts, as I said. V output of the contrast one, use a 10K pot to adjust and regulate the voltage so that you actually get the right contrast. This is read select. We're just going to connect this to another pin. They call this P15 because they're basing this off of one of the old microcontrollers, which is the LPC 1768. But again, you can just use any other digital pin you want. It's just some arbitrary digital pin needs to control this one. Read write, this one is going to be 0 volts. Enable can be some other digital pin, and then digital pins 0 to 3 we're not going to connect to anything, and then digital pins 4 to 7 we're going to connect to some arbitrary digital pin that we're just going to go ahead and use. So that's just pretty much how you connect it up, and then we're going to go ahead and look at the library itself, and we're going to go ahead and write some code to use the library. Okay, so before we even start programming, we're going to go ahead and connect this up, because the way that you program this is highly dependent on how you wire this. So what we have here is the LCD display, and I already have pins connected to the top, so we're going to go ahead and just throw this onto the breadboard. The first thing we're going to do is we're actually going to attach a potentiometer to this board as well, because the reason why we have this potentiometer, again, one of these pins, V0 or V out, helps to adjust the contrast, and you need to give it a variable voltage to adjust it accordingly, so we're going to have to put that down as well. Now the potentiometer and the LCD display need 5 volts to be powered, so we're going to go ahead and connect the 5 volt line on the microcontroller to the power line over here. So we're going to go ahead and locate 5 volts on this. So 5 volts in this case is right here, so it's 4 pins down, or 4 pins up from here. Go ahead and connect that, and connect this to the power line. And then we need to connect a ground to the ground line, because we're going to use ground a lot. So go ahead and get ground, and connect this to ground. Okay, so the potentiometer needs the 5 volt and the 0 volt supply, so we're going to go ahead and connect the power line to one of the ends of the potentiometer. So we're going to go ahead and connect it here, and then the other one needs ground, so we're going to go ahead and connect ground to the next one. Okay. Once we have that set up, now we need to connect the middle pin, which is the one that actually gives up the variable voltage, to the pin pin 3, which is V out. So we're going to go ahead and do that. So this goes to pin 3, 1, 2, 3. And the way that you can tell by the pin number is this is pin 1. Always the top left side is pin 1, and it goes down, it's pin 18. So pin 1, 2, 3, 4, 5, 6, 7, it goes down like that. So pin 1 is VSS, as we know, or 0 volts. We're going to go ahead and connect pin 1 to 0 volts. Okay, and the next one is VDD. Pin 2 is VDD, which is 5 volts. We're going to go ahead and connect that to 5 volts. Okay, and then you actually can see there's actually contrast on the LCD display. So this is helps to let you know whether or not you power it up properly or not. And if you rotate the potentiometer, you can actually make it a little bit. You can make it fade out and fade in. So this will help to adjust the contrast of the LCD display. All right. So now that we have the power on the LCD display, now we need to connect the digital pins that will interface with this. So next one is read select, or RS, or register select. So that's the 4th pin, and we're going to connect this to any arbitrary digital pin that we want. But the thing is, because this LCD display uses 6 pins to operate, you can actually use the top left 6 right here is what we're actually going to be using for this tutorial. So we're going to be using the first top pin is going to be for the register select, so pin 4. So that's right after V output. The next one is read write, which we're not going to be using. And instead, we're going to be connecting this to 0 volts. Okay, now that we have that connected to 0 volts, we're going to go ahead and look at the next one. The next pin is enable, which is pin 6. That's going to be connected to another digital pin, so we're going to connect it to the top left right here. Okay, that's the next one. Okay, so down from there we have digital pin 0, 1, 2, 3, which we don't want to use. So pins 7, 8, 9, 10 are completely going to be empty. And then we're going to start from digital pin 4, 5, 6, 7, and 8. 4, 5, 6, 7, sorry, which is going to be connected to any sort of random digital pin on the microcontroller. Again, we're going to be using the top remaining 4 on this KL25Z to operate it. So we're going to go ahead. So pin 11 is where we get digital pin 4 on the LCD display. So find pin 11 is pin 6, and then this is 7, 8, 9, 10, 11. So 11 is right here, and we're connected to the next digital pin on the microcontroller. And we're going to go ahead and just attach the rest onto this. Connect this over to here. And then we need just one last wire, and that should do it for at least the basic programming of the LCD display. Again, there's additional ones on this for backlight, but I'm not going to be too worried about it. I guess for the sake of just proving that it works, I'm just going to connect pin 15 on this, which is the power supply for the LEDs, to the 5-volt line. And I mean, just for the sake of proof of concept, if I connect this to ground and I connect this to any other pins, it'll have a different color backlight. Yeah. Yep, that should be it. And that should be the setup. And we're going to have to figure out what these pins are, because these are the ones that we use to drive the LCD display. So we're going to go ahead and do that in programming and just look through one of the little spec sheets on the KL25Z, or the image of it, and just map those pins onto our program. All right, so right here is an image of the KL25Z pinouts. As you can see, we use the bottom 6 right here, so I'm just going to go ahead and have this as a reference as we write the code up to interface with the LCD display. So I'm going to go ahead and scroll to the compiler, and let's go ahead and get started. So hit new, and we're going to go ahead and make a new program. So what you can do is you can use the empty program option, but I like to use one of these templates, because the idea of one of these templates is actually provide you some some code that actually works, and it also has imported the MBED library, so you don't actually have to do that yourself. So I'm going to just go ahead and do that, and I'm going to go and just call this LCD test. All right, hit OK. Okay, as you can clearly tell, they made a main.c++ file, and I also imported the MBED library, so you don't have to do that yourself. Of course, what we're going to do is actually delete all the guts here. So what this code previously did is it just got one of the LEDs and it just blinked it on and off. So let's go ahead and just delete the guts. All right, so we now have a blank C++ file, main C++ file that we're going to go ahead and add our code into. But before we begin, go ahead and try and import the text LCD library. So it's right over here. I actually automatically search for text, but it should be the second option if you just don't put anything in the search bar. But so anyways, I'm just going to go ahead and click this and import it into the program. Okay, so it imported in, and if you want, go over here and go to classes and go to text LCD and double click that, and what you can actually have is an API. It gives you the API reference for all the functions needed to actually use this class. So the first one in mind, and it gives you actually some sample code right here to actually instantiate the LCD display and just one printf option. And as you can see over here, to instantiate it, it uses this setup. So you want to use the first pin has to be your read select, register select, then it's enabled, then digital pin 4, then 5, then 6, then 7, and the last one is to determine exactly the LCD display type. So ours is 16 by 2, so that's what it is by default, so we're not going to actually add anything there. So let's go ahead and begin. So first off, of course, you want to actually include the library, so I'm going to hit include, then say text LCD.h. All right, and with that, we're going to go ahead and instantiate the text LCD class. So we can go ahead and say text LCD. We're going to go ahead and name this something, so we're just going to say LCD. And as you can clearly see over here, again, that its first one is a register select. So we're going to go ahead and see right here that it is PTE20 is what we want. So that's PTE20. And the next one should be PTE21 because we just went from the top all the way down to the bottom. So PTE21, then 22, then 23, then 29, and then 30. So I'm going to go ahead and do that. So PTE20, then PTE21, then PTE22, then PTE23, then PTE29, and then PTE30. All right, so that has all the pin maps, and just double check, yeah, so we did have digital pin 7 as PTE30. This is digital pin 6, 5, and there's digital pin 4. So we're pretty much good here. But if you want, you can go ahead and there's that option right there where you can actually input the type that you kind of LCD display that you want. So if you actually click over here, it'll list you the options. So some of the options are the 16 by 2, which is the one that we're using, 16 by 2 bytes with the alternative addressing. That's another option. So what we're going to do, actually, just to make it so that this actually has all the input options, we're going to go ahead and just type in text LCD 2 colons and this thing right here, which is LCD 16 by 2. So LCD 16 by 2. So what this pretty much means before actually showing the LCD 16 by 2, this means that we just got this from the text LCD library, nothing more, nothing less. So let's go ahead and begin. So let's just do something really basic, just like what they had in the main program, which is actually just print something out. So let's go ahead and before we actually do that, there's an option here. It's called clear screen. So it's lcd.cls. That means to clear the entire screen. So if there's anything on the screen previous to this, it'll actually remove it all and take it all away. And then you want to go ahead and just give it some time just to set itself up. So we're going to just make it wait 1 millisecond. Then after that, we're going to do lcd.printf and make it say hello world. And then after that, we can go ahead and actually reposition where we want to go print something. So the way that this works is that after the clear screen, it goes ahead and prints this on the very top line. So we have 2 lines. We actually have 2 rows where we can actually write stuff down. And so the way to actually reposition where you want to actually print something else, you use this one function called locate. So it should be right here, locate. So you can actually reposition the cursor of where you actually want to start printing by using this one little function. And you actually just input the column that you want to set it to and the row you want to actually set it to. The funny thing you have to keep in mind with this is that everything starts counting at 0. So row 0 is actually the first row, and then row 1 is the second row. That's the same thing for the column as well. So what I want to go ahead and do is now reposition it so that it's actually on the second line. So that means the second row. So I want to go ahead and say lcd.locate. I want this on the first part of the column, so that means 0. And I want the second row, which means I want this to be set to 1. And once we have that all set up, let's go ahead and just print something out. Just say lcd.printf. It works. And that should be pretty much it. So again, it's going to clear the screen, give some time. Then at the very top line, it's going to print out hello world. Then we're going to go ahead and change the cursor so it's at the bottom row, and then print out it works. And this should be it. So I'm going to go ahead and hit compile and have it run. Okay, so I have it all hooked up and wired up, and I'm going to go ahead and hit reset on the microcontroller to actually see if it displays anything. So I'm going to hit reset, and you actually know what do you see? Hello world, and it works. And if you want, you can go ahead and adjust the contrast again. You want to just rotate the potentiometer so it actually dims out. And again, the idea is like you don't want to have like a set resistor for this, because every single LCD display is going to have a it's going to have a different type of voltage that it needs to actually display this as well. So that's exactly how you use the LCD display. But we're going to go ahead and do a few more fun things that we can do with this. So we can go ahead and create maybe a countdown system. So it'll time itself down and it'll print something out instead. So we're going to go ahead and just do that with the next tutorial on the LCD display. Okay, so this is the old code that we had over here, and this pretty much did exactly what we wanted to do. But we're going to go ahead and have a little bit of fun with this, and we're going to make it so that it's going to count down something, and then we'll make it say hello world just for the sake of it. So we're going to go ahead and just comment this out, just so that we have space to do it. So if you haven't noticed already, you can actually create comments, mass scale comments, by just putting a / an asterisk, and then wherever you want to stop the comment, you put an asterisk and a backslash. Actually, a / my bad. All right, so we're going to go ahead and again, it's just a good practice to just type lcd.clearscreen. The reason why I'm doing this is that when I programmed this one, it actually lost the first character. So instead of saying hello world, it actually said hello world. Okay, so lcd.clearscreen, we're going to make it wait. And then now we're going to go ahead and we're going to make a counter. So what we're going to do is we're going to say int counter is equal to 5. And then we're going to go ahead and print this out. So the idea is we want to make it so that it counts down as we go. So we're going to make a for loop to do this. So I'm going to say int j, or int I, is equal to 0. And then I is, actually it might be better, instead of actually typing counter, we could actually just use the for loop. So let's go and do that instead. So I'm going to say int I is equal to 10. Actually, we'll use 8. I is greater than or equal to 0, and I plus plus, so we're going to, actually I minus minus, so we're going to actually decrease by a value of 1. And so what we're going to do here is we're going to print out that number. We're going to count down on this, so it's going to say 8, and then every second it's going to say drop down for 1, so 8, 7, 6, 5, 4, 3, 2, 1, and then it's going to print out hello world. So we're going to go and type in lcd.printf. Well, first off, we're going to go ahead and type lcd.clearscreen, because what that's going to do is it's going to have to remove everything. And then you're going to say lcd.printf. And how this works is you're going to use a parentheses, or a % d, and then end parentheses, actually end quotes, comma, and then the number I. So the way that this works is that, unfortunately, printf can take only in characters or strings. So to convert the integer into a character, what you want to do is you want to use %d, so it'll say oh, this is a decimal number or a digit number. So what I'm going to do is I'm going to locate the next argument in, which is I, and replace that, convert it into a character, and put it in here. So what this is going to do, this for loop is going to clear the screen, then it's going to print out the number 8, then it's going to start all over again, and it's going to go down to 7. And to make it so it counts in seconds, we're going to make it wait for a second. Okay, so once that's done, then we're going to go ahead and do clear screen again, and do lcd.printf hello world. I'm going to let it compile, and we're going to go ahead and upload this code up, and let's see it work. Okay, so we have this in the previous format. I'm going to go ahead and hit the reset button on the microcontroller, and it should run the program. So I'm going to hit reset, and now it says 6, 5, 4, 3, 2, 1, and then it's going to print a hello world. There we go. Okay, so that's a little fun thing you can do with the LCD display. There's also a variety of other functions that are methods that you can find with this library itself. These are just the basic ones again, and then you can also, if you want, in this library, you can also actually custom create your own characters. So if you want to make like a degree symbol or some sort of like a Greek symbol, you can go ahead and do that with the library, and there's the website available, so you can actually read up on how to do that. And that pretty much covers exactly how you program an LCD display.